Sometimes that's because copper is a metal. If it's a gas, the gas will go. It will liberate. So the arrow goes upwards. I'm not always saying that there will be a precipitate. It could be a liberation of a gas as well. Okay. So either way, the higher reactivity or higher reactive element or metal will displace the lower reactive metal from the compound, from its compound, and take its place. Now, we have got copper sulfate. What is the color of copper sulfate? Blue. Right? So, we have taken copper sulfate, put in a beaker, and we have shaken it. That means copper sulfate got dissolved, and the whole solution is blue. Yes or no? Just imagine this. Now I added iron dust or iron filings, and I am shaking both of them together. What is happening while I'm shaking it? Yeah. What is happening while I'm shaking iron and copper sulfate together? Iron is getting converted into iron sulfate. How is it getting converted into iron sulfate?
It is displacing copper of copper sulfate with iron, becoming iron.
Okay. How do you know when you have to stop shaking? Are you going to keep on shaking all day, all night? Huh? When will you stop shaking the contents of that beaker?
When you see a precipitate.
Suppose you don't see the precipitate.
When the solution will turn green.
When the
Solution will turn green.
Never mind what color. When the color changes.
Yeah.
Why has the color changed?
Green.
Why has the color changed?
The color has changed because the iron has displaced copper, and iron plus copper. Iron sulfate is
Reaction has taken.
Yeah. Can anyone tell me? Why has the color changed? Why has the color changed? Why has the color changed?
That's the color of iron sulfate.
Yeah, because it's no more copper sulfate. It's now become iron sulfate. Donkeys. First class, first degree, 99.99% donkeys. It is no more copper sulfate. It has now become iron sulfate. And you compound this form so the color has changed. Okay? And they say that the color should be green in color. Okay, so green actually doesn't mean green. It's a different color altogether. Crystals of Fe sulfate are green. The solution is actually dirtyish brown because iron hasn't really, it's only physically combined with that sulfate. Okay? But just remember that the color of copper sulfate has disappeared. So we stop shaking. Why? Because there's no more copper sulfate. It is now iron sulfate. Okay? Alright. So now suppose I give you this particular reaction. Okay? What will be the answer? What is wrong with you? What is wrong with you? Will you behave yourself? If you want to sit in my class, I will out. You want to behave the way you want to behave, that behavior is fit for the roadside. Not for my class. Have I made myself clear to you? Don't let me correct you. Give me the reaction here.
CuSO4.
Okay. CuSO4 and then plus
Zn.
You are a donkey. I said 99.99%. You are 101% a donkey. Is copper more reactive than zinc? So then, what will be the reaction? What will be the reaction? There will be no reaction because zinc copper cannot displace zinc from zinc sulfate. Why? Because copper is lower than zinc in the reactivity series, so there will be no reaction. This is what you can't think, children. So smart you are now. Show your smartness here. There will be no reaction. Why? Because copper cannot displace zinc from zinc sulfate. Why? Because copper is lower than zinc in the reactivity series. So whenever any reaction is given to you, first see the position of the metal and then you go about giving the product, then you go about balancing the equation. Don't go blindly and do it. Have you understood? Do not go blindly and do it. Look at the metals. That's why I said learn the reactivity series first. And then you will know which reaction is going to proceed till the end or which reaction will not take place at all. So this reaction will not take place at all. So what do you know about a displacement reaction? A displacement reaction is a reaction wherein one metal will displace the other metal from its compound and take its place. Okay? Now, the metal or the element that is displacing the metal or the element from the compound will be more or highly reactive than the metal present in the compound. For a displacement reaction, second point, for a displacement reaction, you need one metal and a compound. Third point, in a displacement reaction, a precipitate may be formed or a gas may be liberated. Is this clear, all of you? Okay. Now we come to double decomposition. What do you understand by double decomposition? First of all, what is meant by decomposition? What is meant by decomposition? Again, I told you do not use the same word when I'm asking you for a meaning. I asked you what is decomposition? It decomposes. I can't understand the meaning of that decomposition. I want to know what do you understand by decomposition? She has not opened the textbook. Of course, somebody has taken a textbook, so she has got no textbook to read. So don't answer any of my question. What is the meaning of decomposition? What's the meaning of decomposition?
Substance breaks down.
Substance breaks down. What else? Substance breaks down and what happens?
Breaks down into forms its products.
And then anything further?
And it is like irreversible.
The products do not combine to give you back the original stuff. That's a very important thing. That's a very important statement to make. In a decomposition reaction, the main compound breaks up to give you its constituents or to give you the products, and the products don't combine to give you back the original substance. Don't combine. Now, when it is double decomposition, in the first case, it was simply decomposition, plain decomposition. So only one compound was participating. Now, two compounds are participating. Now, what happens here in two compounds? Suppose we have got here ferrous chloride, FeCl2, okay, plus you've got here copper sulfate. Two compounds, correct? Which of the two compounds is going to start the reaction? Can you tell me? Yeah, that brown t-shirt. Brown t-shirt. That's not brown. What color is that? Huh?
Pink.
It's pink.
Yeah, it's pink.
What?
It's pink.
It's not pink.
It's pink.
It's okay.
FeCl2 is going to start.
It's going to survive.
Because it has Fe and Fe is higher than C.
Correct. Of the two, which is going to start the reaction, immediately low. See, wait a minute. This is metal, this is non-metal. That's the way you write a compound. Always metal is written first and the non-metal afterwards. Again, metal and non-metal. Okay. Now who's going to start the reaction? The highly reactive metal. The highly reactive metal will displace the metal and take its place. Okay. And what's going to happen? This will come and take its place here. Double decomposition, double displacement. It's a double displacement. In other words, double decomposition. So Fe will cut off copper, and what are you going to get then? Fe sulfate, correct? And copper will come and take the place of Fe, and you're going to get copper chloride. Just interchanging of cations. Metallic ions are called cations. Now, in a double decomposition reaction, a precipitate is always found. No gas is liberated. There is no liberation of a gas, but there is deposition of a precipitate. This is clear? Of the two, this is going to be the precipitate. Okay? Now, if this quantity is more, then this will be the precipitate. Okay? So it all depends upon the quantity of the original reactants. But a precipitate is always formed. So a double decomposition reaction is also called a precipitation reaction. Okay? Now, but all precipitation reactions are not double decomposition. All double decomposition reactions are precipitation reactions. But all precipitation reactions are not double decomposition. I didn't say the reverse. Okay? Now, also remember that, as I said, a precipitation reaction, so this will be the precipitate here. It's a precipitation reaction, it's also a double decomposition reaction. Double decomposition reaction is also a neutralization reaction. All neutralization reactions are double decomposition. HCl plus NaOH. Okay, acid and a base will give you what? Salt and water. NaCl plus water. Okay, all right. So you have got your Na will displace H, because Na is more reactive than hydrogen, or Na is in the higher position than hydrogen. So Na will take the place of Cl and H will take the place of OH and give you water. This is a neutralization reaction. Could use acid and base, and it is double decomposition. So, what is this something?
There is no precipitate in this, right?
Here there is no precipitate. Here this is neutralization. So what is a double decomposition reaction? A double decomposition reaction is a reaction wherein two compounds are participating, okay? And the element, more reactive element in one compound displaces, okay, the cation in the other compound and takes its place, and the cation, the anion from that, the cation from the second compound occupies the place of the cation in the first compound. Secondly, in a double decomposition reaction, a precipitate is also and always found. Okay, all double decomposition reactions are precipitated or precipitation reactions. All neutralization reactions are double decomposition reactions. There are 4 points. Who has not understood this? Raise your hands. All of you followed? Right? Now read. I finished up the chapter with this. Okay. Then I will just have to give you examples of types of reactions like exothermic, endothermic, then thermal decomposition. Then I've got to do electrolytic, photochemical, photo and electrical. Come on, I think I already did with you. I've already done it with you. But you were absent that day. Once you went to one point, this point, that point, go there and stay on and watch all the points in Bombay. Come on, hurry up, read that. Huh?
FeSO4 is soluble, right?
Not always. It depends upon what the solution solvent is. No, always. It all depends. But actually, I say FeSO4 is soluble. That's definitely correct. If the solvent is water. Okay.
Is there promoter for negative catalysis?
Is there a promoter? Oh, yes, it could be. Why not?
Negative catalysis.
Yeah, the one that slows down the reaction. Oh, yeah, if it's not working efficiently, why do you need a promoter? When you have, it has to enhance the workability of the, yes. So if the negative catalyst is not working efficiently, for whatever reasons, then you have to use a helper. Promoter is a helper.
So promoter is neutral.
Either way.
Positive or
Either way, either way, either way.
what we call
When there are more than four oxygens atoms, forgot. Just turn over the page and see. It's for no. For you're asking me. Actually, if you take out N2 and 4, 2 you take out common, so it will be NO2, nitrogen dioxide. Ah.
What is milk of magnesium? Milk of magnesium.
Milk of magnesia is actually a particular, I don't know whether you've seen it. It's like gellucidizing. See, sometimes when you eat outside food and you get a burning sensation, mainly older people suffer from it. Young people,
Acidity.
okay. Huh? It's acidity. What has happened is the HCl in your body has released extra, okay, and that creates this burning sensation. Now, if acid is extra in your body, how will you neutralize it?
by
By adding a base.
Consuming
By adding a base. That base that you can take in, which is edible, which is medicated, is milk of magnesia. It is white in color. Magnesium sulfate. It is white in color. Hydroxide. It is white in color. All hydroxides, calcium hydroxide, magnesium hydroxide, these are all white in color. Milk of magnesia, white in color.
It looks like milk only.
Absolutely like milk. And immediately it gives you a relief. Now they have it in the form of tablet, gellucil, pink color tablets are there, which releases that uncomfortable feeling that you have when you're overeating. Finish reading That's to kill the acidity in the body. Milk of magnesia. Rub out the board. And okay, one moment. Sit down there. I'll give you a question first. Now, different types of reaction that I've taught you are exothermic reaction. What is an exothermic reaction?
The reaction in which heat is given.
Heat is given out, correct? Go and write on the one equation on the board. Close the books. Close the books. Close the books, all of you. Close your books. And when I say close, means immediately. Quick. Immediate. You don't know. Who knows? Any reaction wherein heat is given out. Go put it on the board. Rub out the board first, and then write it down.
Which part should I?
So,
Huh?
who was asking?
Why took so long to come? You left home early, no? I didn't see you. You left in time. 6:30, I'll leave you for the 6:30 lecture. Then, what time you left home? 6:15. And why you took so long to come here? What? Where did you go? Huh? It takes 15 minutes for you to come from there to here. Right? More than 15 minutes you took. You gave it 6:35. Where did you go?
Should I balance? Should I balance it?
You should never ask me that question. What is the equation you are giving me?
Like when we add sodium to water.
Such a, this is explosive reaction, you gather. I told you, give me and so I know the heat is so much that this sketch will catch fire. Hydrogen is there. It catch fire. Okay, balanced equation, no problem. It's a perfect reaction. Come on, balance. Correct. Okay. Next one. Go. So this is an exothermic reaction. Now, next one. What's the endothermic reaction?
Reaction with takes in heat.
Or which is in which heat is required to start the reaction. Okay, me. Put on the board. Hurry up. I'll smash you. Come on, go. Do you know? You. You don't know? You. You want to go on the board, no?
Just balance it.
Do it on the board. I can give you a nice knock on your head if you go wrong. What are you telling me? What reaction are you giving me?
Potassium plus water.
What is the name of the reaction?
And exothermic.
And what is the name of endothermic?
Endothermic which takes the heat from sun.
Yeah, okay. Wrong. This is wrong. Absolutely wrong. That and that reaction are the same. Both of them will react similar. This is exothermic. I asked you endothermic.
So you have this.
You're planning to make me mad or what? I'm already half mad, okay?
Endothermic.
This is the real section. I'll go.
No,
I gave you a chance. You thought what? Stop thinking. Just remember what I'm trying to tell you. Do you know? Who knows? Endothermic reaction. Calcium carbonate on heating will give you calcium oxide plus carbon dioxide. I just told you last time all carbonates when heated will give you carbon dioxide and metal oxide. Did I not tell you metal oxide with hydroxides, with carbonates and with nitrates? I told you that or not? No, I think I taught you last year or maybe 2 centuries ago. Sorry, I made a mistake. I thought I taught you last time. No, I must have taught you 2 centuries ago. You will have forgotten. You'll have not bothered to open up your books and read. Not bother to even check. You will check and study your work only when next day there's a test. I'm going to make sure the UT class never tells you that you are going to have a test. Give you a surprise test. I'll do that. I'll do that. Then we will see how smart you are. So, in this case, heat is evolved minus, that means heat is getting out of that reaction. In this case, calcium carbonate, okay, on heating will give you calcium oxide plus carbon dioxide, okay. So this is your endothermic reaction. Then comes electrical reaction, meaning when you need electricity for electrochemical reaction. Heat.
Potassium plus chlorine. No, potassium chloride or.
Go on the board and write it down. I don't know. Okay. Now, photochemical reaction. Come on, photochemical reaction. Photo means what? What? Again, when you're told to answer, you don't answer. When you are giving the chance to somebody else, you answer. Photo means what?
Light.
So,
Photosynthesis.
yes, okay.
So,
Sunlight that gives you oxygen and um, what is it?
Water.
Yeah, water.
It's not complete. What is the food material that you get? Oxygen you get plus what?
glucose.
Then?
So, no.
Okay. Absolutely rubbish. That 6 is wrong. Just
Yeah, I can't erase it.
you've got fingers, no? Wrong. The balancing is not complete. The balancing is not complete.
IR6.
I don't know. You have to change. Look in front and you do it. Don't look at any one of them. Okay, if that is 6 2s are 12, what about here? Oh, Jesus, this girl. You're not using your brains. Will you please use your head and look at it? Do you know how to balance the equation? Huh?
Can I do it?
Why you can't do it here? What's happening here?
I don't know. It's just like the board. I'll just do it on the notebook.
Go right to the back and do it.
I'll show it to you on the notebook.
Yeah. Who can balance this equation? Ian, go and balance this equation.
I'll do it on my
Okay, let me. You go ahead and make it. Huh? Huh? You know? That doesn't matter, but this equation is to be balanced. Go and balance this equation. Hurry up. Get up and balance this equation. Quick. Quick, 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 don't waste time. Go and balance the equation.
Now I got it. Now I got it. That's a 6, sorry. Yours is 6 years.
Oh, 6 carbon. Huh?
Yeah.
So 6 carbon. Huh?
That is not carbon, that is oxygen. That is
6. Okay, 6 oxygen.
correct.
6 to the 12.
Yeah.
And 1 13. 13 and 6 is 19. And here I want this 6, 12, 18.
Oh, so
Check.
can I check it?
Okay. Six carbon, correct?
Yeah.
Now 6 twos are 12, isn't it? 12. 6 and no, it won't come there.
Yeah.
Make that 12. Water's 12. Make water 12.
Now
Make
I got it.
12. Okay. Now 12, that is 12 to the 24, isn't it? 24. So this is 12. 12. This is 12. And then that will be what? Make that 6 to the 12. 6, water 6.
This,
Here, water 6. So that becomes 24. Now it's okay. Now you balance it. 6 twos are 12 and 12 and 12, 24. Oxygen is 24. Yes, that is, yeah, this is 6 and this is 6. That is 12 and that will be what?
this,
That will be 6 twos are 12. Another 6, oxygen is 6. 6 twos are 12 and then 6, 12, 18, 19, 20. Correct. Now it's balanced. These are bigger numbers. Okay, so we've got now, the first one is thermal circuit. First one is exothermic. Second one is thermal decomposition. Third one is electrical decomposition. Fourth one is photo decomposition. Another example for photo decomposition is your silver nitrate, silver compound. All silver compounds will get decomposed in the presence of light, any light, whether it is tube light, artificial light, or sunlight. Okay. Now, okay, with that I have finished up. These are examples of energy related chemical reaction. Energy in the form of heat, light, and electricity. Okay. Now you can work out, read the whole chapter and work out all the problems at the back of the chapter. Because after the next lesson, I'll start with water. Come on, hurry up. Hey, why are you talking?
I was just seeing this question.
Huh?
I was curious about this question.
You are curious about
That
that book, why?
it looks intriguing.
Put it. Yeah, put it. It's read and then start writing down the answers at the back of the chapter, including all the equations. Hurry up. Dalal has got plenty of working examples. Plenty. And I'm scared to ask whether you'll have finished up the question and answers of the first chapter. I don't want to ask and I don't want to know because I know the answer is we have not finished. All. Okay.
Like more questions. This new textbook has got like more questions. It's a lot.
Do it. What is it?
Yeah.
How many of you have not understood the chapter? How many of you have not understood this chapter? Raise your hand. Have you finished up the chapter in school?
Yeah, almost. Yeah. Tomorrow I have a presentation.
The teacher explains everything in detail from the textbook.
So we have presentation. We have
Presentation
half the
means
chapter we do half that.
come on, hurry up. Tomorrow there's no English class, huh? Tomorrow the class is cancelled. Have I been informed about it? How many of you are taking English? Don't come tomorrow. I'm not coming. I'm taking I'm on leave tomorrow. Next Saturday I'll take Julius Caesar. Have you started with Julius Caesar in
No,
school?
we're going to start
Just
in
like
June.
student.
At my school, the teacher started a poem on Saturday.
Which one?
Cambridge and
Oh yeah, Cambridge Science. Yeah, the cat. I finished. You were there for English. And you were there for yes, you were there for all the two poems and one lesson. I finished. And I got to do Julius Caesar. Next time I'll start with Cambridge Science. You're not having any tests now, no, in this month of May. So it's June only, no? By the time I should finish up.
I have a doubt in English.
Huh?
In English.
What is it?
When our teacher explained, I remember. So that time she said that the poet is not actually ill because of that line, that fever on my throat.
So she
Bravo,
said that so she said that he's too tense stressed, but he's not actually ill. But you said that he's ill.
He is ill. He is ill.
What?
You are from which school?
Non-point Bernadine.
Bunny man said it. What about your? What did your school say?
Same.
No, but your for that.
Yes, not Goku router.
You all
We started
That is-
all over us for more. And we finished.
are in anyone which was no.
We have done it.
Yeah. So then did the teacher say you're from French school, no? Then the teacher has told you that means you're from North Point, no? So the teacher will tell you the same teacher, no? So there are two teachers in one did ma'am. No?
What did she tell you? That she started with.
You're not in the same class?
No.
Different divisions. Let's check from Google, no? Why are you talking now? I will start with your writing. Huh?
Yeah, we're just revising.
Okay, you take it as distress. It is causing some. What actually happens is sometimes when you are having a mental problem, it creates a physical disability. So you can say that he was mentally distressed, which was creating that sickness.
So he was not
Okay.
ill.
Huh?
He was not actually ill.
He was just no. Don't say it was. Just say he was mentally distressed. That's okay. Mentally distressed.
Suicidal. Suicidal.
Huh?
Suicidal.
Suicide.
No. Not
But
suicidal.
he said he wanted to die.
He was hoping that the night would take his breath away, that the night would take the breath away, that he would die a natural death, not commit suicide. Committing suicide is taking away your own life, and night taking it away means he is dying naturally. That's a different thing. But he had that the feeling of wanting to pass from this world, okay, but not taking his own life. No, he was distressed. He was not desperate. Have you finished your question and answers? Why are you dreaming in? Start writing. Take the board.
See, there's nothing.